Good morning and good afternoon, everyone, and welcome to this roundtable on sustainable mobility as part of the third annual Canada-Italy Forum on Artificial Intelligence. A forum whose theme this year is artificial intelligence and the challenge of sustainability. There's no doubt that sustainable mobility will play a crucial role in the implementation of a more carbon-neutral world in the near future. And to this end, we felt that it would be interesting this morning and this afternoon to explore initiatives related to artificial intelligence that contribute actively to this goal today. My name is Aymeric Dussart. Thank you for joining us. I'm the Vice President, Technology and Innovation and Chief Information Officer for Aéroport de Montréal, the organization that manages and operates Montreal Trudeau International Airport. I will be the moderator for this session today. And I'm also joined today by Desiree Tremblay, who will act as rapporteur for the organization for this session. She's manager R&D partnerships and grants for Dana TM4, and as an expert in sustainable mobility, she will be capturing key findings and conclusions, and certainly future research themes that will come out from this session today. We have divided this morning's session in two parts, actually. In the first part, we will discuss autonomous and connected vehicles and open data strategies. So we will be having 5 guests speaking on that specific topic. And following this discussion, following these presentations by each of the guests, we will have an open discussion on the different themes that were covered during the presentations. In the second part, we will discuss the use of AI for simulation and digital twins, another very hot topic these days. And again, we will use the same format. We have 3 guests for this second part that will be presenting their research topic, the work they're doing right now. And following those individual presentations, again, we will take some time to have questions and to discuss the different themes that have been covered during the presentations. We have quite a busy schedule this morning, so we'll be starting right now. So the first part, as I just mentioned, is on autonomous and connected vehicles, open data and sharing data. And our first speaker today comes from the University of Modena, Professor Marko Bertogna. Professor Bertogna is a full professor and leader of the Hypert Lab. His main research interests are in high-performance real-time systems, especially based on multi- and many-core devices, autonomous driving, and industrial automation systems. He holds a PhD in computer science from the Scuola Superiore Sant'Anna of Pisa, senior member of IEEE, stakeholder member of HIPAC, and is also CEO and founder of the academic spin-off Hypert. Professor Bertogna, I'll let you do your presentation.
Thank you, Aymeric, and thank you guys for inviting me. So, as the session is on autonomous mobility and its impact on next generation application, let me first try and introduce what we do. So I'm a full professor here in Modena, in the University of Modena, which is in the very center of the Motor Valley, so full of a lot of very worldwide renowned companies like Ferrari, Maserati, Dallara, Pagani, Lamborghini, and so on. But we are computer scientists, so we have been working on computers since 20 years ago, since the start of my PhD, and when we founded this lab that tried to intercept this big change, this big paradigmatic shift that we are having about automotive and not only. So all these objects are becoming ever more compute intensive and electronics object rather than mechanical objects like we were used to. If I can simplify what we do, we essentially try to anticipate this trend and understand how modern computing platforms, especially modern high performance and embedded platforms, would evolve in the future, and what kind of application, the AI-driven application, could, let's say, reshape the future of mobility and especially automotive mobility. So now the group grew up very much. We are over 70 people nowadays. We also founded 2 spin-offs working in this domain. And yeah, we essentially play a lot with what artificial intelligence can do with not only cars, but everything that moves. So the motto of our spin-off is essentially that everything that moves can become autonomous and therefore will become autonomous, okay? So better to try and play with it in advance, try to anticipate this trend and see and do and show with this kind of prototypes to test and check what can be done out of it. So currently, I mean, the typical application that we started with already 8 years ago was trying to make a car autonomous in a, let's say, simple environment and control environments. And from then, we are starting to like increase the complexity of each of the typical stages of the autonomous driving pipeline. So just to explain it briefly, it's not just simple AI. So AI is a term where that can combine almost everything, but there are 3 typical stages in an autonomous car, as in all autonomous robots around. So the first one is the perception. So try to understand the environment, and that's typically is done by fusing the inputs from multiple sensors. So our cars are full of cameras or laser scanners or other kind of sensor that we mount on different kind of drones like radars or sonar when we go and run in underwater scenarios and so on. So we really like to play with different kind of domains. So again, not only car and typical urban platform, but also like delivery bots or like surface, water surface catamarans that are made autonomous, and they may deploy different kind of robots also to explore what you can find at the sea bottom and autonomously operate them without requiring any help from an operator. So this is perception. Again, a lot of sensor, you need to fuse them in real time and understand where you are and where everyone else is. Second stage is planning. Okay, so path planning. Path planning is not just taking Google Maps and try to understand which path is the shorter one, but try to understand the dynamics of the vehicle, try to understand based on the location of your other agents, for the other entities that you perceived in the first step, try to plan your path accordingly and understand where you can drive safely. The third step is instead the actuation itself. So how do you give your outputs to the steering wheel, accelerator, pedal, or brake, and so on, in case of a car, or to the drones, to the engines of a quadrotor or whatever. So this is the third part that typically requires very real-time friendly decisions that are able to smoothly operate your robot or your car. So connected to AI. So AI improved very much, incredibly much, the first stage. So perception. Perception now is incredibly better than it was just 5 years ago or 10 years ago. So we can do way more just with simple and commercial cameras. So we can elaborate and fuse the data coming from cameras and extrapolating a lot of intelligence out of this kind of information. Also, the planning has been improved thanks to some AI-driven technique, but still the more classical control-driven routines are preferable, at least at this stage. And also, as we typically like to do that and take it to extreme. So we also like to participate in extreme events that take this difficult condition to the edge. So try to play the difficult case, so to be better playing the simple and average case. So the last crazy thing we've done is participating to this Indianapolis autonomous challenge that has been just took place a few weeks ago, and we arrived second. We almost won, but it was like a lot of experience to understand how to control a car in extreme environment at the limit of handling. So really at the edge of losing control of the car at 250 kilometers per hour and so on. Connected instead to urban mobility and to how AI can help from an infrastructure and smart city setting, we also deployed in Modena, from where I'm talking to you guys today. There's a MASA initiative. MASA is an acronym that stands for Modern Automotive Smart Area. And it's essentially an open lab that we invite everyone to take part. We are very open to it. And it essentially tries to answer the question, what could the infrastructure come and get handy for next generation application, especially autonomous driving, but not only autonomous car, also connected car and advanced driving assistance systems and so on. So our answer was to deploy in the city of Modena tens of cameras with intelligence right on the edge. So we integrated, edge processor, so embedded processor with special routines and deep learning algorithms to be able to elaborate in real time all the feeds coming from these smart cameras, and in real time understanding where a car is, its exact position, where a pedestrian, a bicycle, a bus, a truck is, and try to track it during the permanence in the control area. So there are many projects that try to do something similar, but to our knowledge, we are the only one doing this in real time. So real time means that we extract the frame, we elaborate it, we run our neural networks, so we run our tracking algorithms, and we communicate this metadata in real time within 100 milliseconds. Okay, so it's a lot of effort to be done in real time. Why such a tight deadlines, such a tight timing requirements? Because if I'm able to do that, then the data will be useful also for autonomous car. So it's like to have, for an autonomous car, to have additional eyes that are sparse around the city and that you can actively use and sensor fuse to have privileged views, privileged point of views also from other angles about solving the first stage, so the most difficult stage, which is the perception stage in such a harsh and difficult environment. So this is just to give you a glimpse of what we do. So we integrated, this is something working both on the infrastructure level and at the edge level. And again, we invite you guys to check it, and you are more than welcome in joining us, whether from the Italian or the Canadian side. Thank you very much.
Thank you very much, Professor Bertogna, for this very insightful, interesting presentation. Our next speaker is Alicia Zarzani. She holds a PhD in environmental design, and she works at Ville de Montréal as an expert in urban planning and shared, innovative, and sustainable mobility. So,
thank you so much.
You're welcome.
Yes, I have a presentation if you want to put them in the... But I'm glad to be here. Thank you so much for the invitation. I'm Alicia Zarzani. I'm the coordinator of the shared mobility for the city of Montreal. And I work for the division of plans and policy. So what kind of work we do at the division of plan and policy is to develop the new strategy to better plan the city of the future.
I just want to make sure we can see your presentation. Can you share it, or is it the?
You have my presentation.
Okay, just a second then.
Yeah.
Thank you very much.
Nothing, it's a pleasure. So one of the most important plan that we are working right now at the city of Montreal and in my division is the general plan to dreaming the Montreal 2050. So in order to make this plan, we answered three questions. The first was, what do we want the city to do like in the future? How we want it to be organized and built? And the third is, under what condition do we want to move around the city? So this last question integrates the role of autonomous mobility. So we studied three types of person autonomous mobility. The first is robotaxi. and the service on demand via reservation with a smartphone, the possibility of carpooling. The second one is the autonomous shuttle in addition to the bus network, so for serving the first and last mile. And the third is the autonomous individual car, so for individual use of the vehicle and the possibility of sharing this car between the family members. So for preparing the city of Montreal, we need to study different categories. The first is the sustainability and the transition, the technological integration, for example, the connecting red light, the managing of urban spaces, the connectivity and the data sharing, and the security and the accessibility. So in the plan, we have an element of a vision for the future. Piloting innovation helps guide the arrivals of autonomous mobility. It's mean for the city to be electric, shared, collective, and compatible with life in the neighborhood. The challenge for the city of Montreal is testing and supervising new form of mobility in regard to have an ecological transition and the collective interest. So what kind of challenge we have of the gradual arrival of autonomous vehicle for the city? The first is the transition period, the decrease of income, parking, offenses, registration, gasoline taxes, new sort of new expenses, for example, the infrastructure, the new connective infrastructure, the access to data, the security, the storage, and the respect of the private life of the citizens. And so others, like the risk of the urban sprawl. So we start in Quebec to have different pilot projects. We have a legal framework to allow to testing. In December 2017, the Ministry of Transport introduced a regulatory power to allow to test the different pilot projects for a maximum duration of 5 years, and with an economic plan that provides 5 million dedicated to the city of Montreal to testing this type of new technology. And the other part, what is the municipal council's mandate? So it's identified different issues. One is the rapid development on technology. The actual regulation need to be upgraded. And the large amount of data then impose some opportunity, but we have some risk to solve. So what the city wants in regard of autonomous vehicles? So one is to promote the electric autonomous vehicles and in the shared mode. The other is the limit the use of personal AV, and to protect the privacy of the citizen and the security of the citizen. For that, the pilot project should be helped to develop the new planning strategy. So we have different multiple objectives. So the first is to test the different contexts in various tests, to familiarize and consult the population, to evaluate the technology needs, the advantage and the risk, to promote the mobility actors collaboration, to influence the technology development, and this is for identify the update that we need in the regulation. So the city developed 3 different projects. The first in a private site, the second one in a residential area, and the third one, this here, in a commercial street, in the Plaza Saint-Hubert. So the autonomous shuttle, the basic premise for this type of technology, and why we test in the commercial street, is because the trip need to be too short for a car and too long for walking. So we developed different phases for the project. The preliminary part is in collaboration with the MTQ for the security of the trip and the zone of the pilot project. The first one is to better understand the technology, and it's right now in the street. And the second part is to better understand the citizen usage. So this is the zone. We have two autonomous electric shuttle, 2 kilometers of trip, a maximum of speed of 20 km/h, 7 stops, 4 traffic lights equipped with connector to allow the shuttle to know when it can cross the intersection, and an operator on board in each shuttle at all times for the security aspect. So we can see some photo for the first phase. This is our shuttle. This is some upgrade to the infrastructure, and some technical integration to be able to develop the pilot project in Plaza San Hubert. So for all to have on board the citizen, we use a COVID mitigation for this phase. So when you come in Montreal, we will be glad to welcome you on board.
Thank you very much for this very interesting, insightful presentation. Thank you. So our next speaker now is Andrea Sanguedolce. He works for, he's managing director for FEV Italia, and he will be presenting some work presently being done at his organizations. So Mr. Sanguedolce.
Yeah, thank you very much, Mr. Dussart. Yeah, if you can share the presentation, or I can do it, no problem.
I'll let you do it actually, so you can change the slides at your own rhythm.
Okay, so.
And let me know if you have issues. I can do it for you as well.
Let me know if you see my screen then.
Yes,
when
we do.
you see my screen. Just a second. Okay. Can you see?
Perfectly, thank you.
Okay, perfect. So good morning and good afternoon, ladies and gentlemen. I would like to thank the Italian-Canada Chamber of Commerce and Regione Piemonte to give me and FEV the possibility to share with you our vision about future mobility and how the artificial intelligence. Let me say, I'd like to start presenting FEV at a glance. You see, we are an engineering company, partner of many OEMs and very relevant tier ones and other players within the future mobility development. We have a global footprint. Revenue are referring to 2019, for sure 2020, as you can imagine, is not a reference year. But let's say in this moment, the development for future mobility is really high in all our customers. So we are really catching up and even growing. So we have more than 300 laboratories around the world to do our jobs. We are for sure an engineering company, so more than 70% of our employees are engineers, or in any case educated through university. More than 200 patents application per year. And so we have the luck really to work with all important, let's say, developers around the world. Plus, we have many internal projects. You see here how we do operate. These are our business unit. So engineering is our business. So how we do our business through this department. We go from vehicle development, powertrain development, and here in this, let's say, business unit, we include all electrification topic of the powertrain, conventional, the hybridization at any level and supported by any alternative fuel, plus the complete, let's say, electrification. It's done within this department. But all these, let's say, all the departments are pretty much supported today by our intelligent and mobility and software business unit. And this is in red because when we talk about artificial intelligence, this is where this is, let's say, considered much more compared to the other view. In this slide, we present, let's say, our approach, which for sure is holistic, as you can imagine. From the bottom, what do you need is really the basic and the fundamentals, let's say, to develop technology applied to autonomous driving and connected vehicle. You see in red, we highlight data science, where artificial intelligence is key. Then the intermediate step, it's for sure you need to have a system engineering view, and this is supported taking into consideration safety and security, all the method and process, up to the end where you need to deliver end to customer experience done by what we already saw, let's say, described a little bit by Professor Bertogna and Mrs. Zarzani. So, and the topic are the same. We are talking about assistant and automated driving and connected vehicle. Data science, data science at the end extract information from data to answer question or solve problem. So in some way, we need to add value of all this data that we have to manage nowadays within this technology. Below you see the technique, so how you can extract value at the best from the data. We are talking about deep learning. I mean, even for me, the difference, it's not so clear sometimes, but we say the deep learning is when you use model, let's say to predict something. Machine learning, you have model and data. And the big difference to reach the artificial intelligence at our level is that which will usually require human intelligence. You want to reach the level where from the data you can extract value and decision that can be taken by human intelligence. This is, let's say, a relevant difference between the machine learning and the artificial intelligence. On the right, what you can see is the domain. Is even the predecessor of me say that we have several domains, not only the normal mobility one from A to B, but we have to consider different environmental, and we have to consider even where you need to have a product that needs productivity. So you need to produce a certain level of work. So really the application are really wide and different. You see here which kind of service FEV provide around the data science can be different: backend service, visualization and reporting, data science, process change design, and again, these are applied to many and different domains. Here, as I said, for us, it's important to extract the value of data. I mean, we don't do any basic development of artificial intelligence as Professor Bertogna at the University of Modena. What do we do? We use, let's say, to analyze, process data. You see for different, let's say, use cases, at least at high level. The one is statistical analysis of real driving emission data. As you know, the emission of even conventional engine or hybrid engine is a big topic today. So the possibility to acquire data during the testing, but even during the life cycle of the vehicle is fundamental to, let's say, to go in the direction of the sustainability, to be sure that the vehicle in that moment is really respecting the regulation. And you can do this real life. For sure, what do you need? You need to process a huge amount of data and to extract a decision to understand if the vehicle, for example, has an issue or not. We go to the second level, off-board root cause analysis. So you can not only measure what or estimating what the emissions are, you can try even to understand if this is drifting from your expectation, which can be the cause, and you can anticipate first, the higher emission of the car, and you can even be much more efficient during, let's say, the fixing of the issue. Then, other system training and validation, we already discussed it. It's for sure an enabler to be able to develop and to apply this system in production. And the last but not least, state-of-the-art prediction. It's a little bit linked again to the, let's say, the monitoring, the diagnosis, and try to predict if you may not have an issue, but you predict that you could have an issue in some times or in facing certain conditions. And this will allow you to anticipate and with the big advantages for the sustainability, the cost, and so on. Yeah, this is just to visualize a little bit, some of the applications that we said. This vision is a bit more cold than the one presented by Mrs. Zarzani, but you see that you have different type of mobility, highway or the urban mobility, and these require totally different development in terms of functionality. But all these use cases needs artificial intelligence as enabler to be able to arrive to the implementation of the functionality. I mean, this is a bit more, I would say, boring slide. It's just analyzing a little bit the development process. I will not stay too much. We go to the next. Yeah, this is a bit more interesting. This is example of projects. So in FEV, as we have internal project, we work for our customer, and this is an example of testing and validation of ADAS and AD function. We are talking about more than level 3. As we know, more than level 3 means that you can stay hands-off for some times in control environmental, for sure, not in all environmentals, and even that your eyes are not looking directly on the street for some time. And to do that, you can imagine it's quite ambitious. From the technology point of view, they are available, but then you need to be able to test and to validate that this can be let's say, put in production, and that the customer is safe using it. Okay, and an example, you see that you need to have for sure prototypes. Sometimes you collect a lot of data, but then you need to have a kind of digital twin or a platform where you identify your driving scenario. That can be downtown of Bologna. We have, by the way, in Bologna, a laboratory that is developed this kind of functionality. We are doing some work with the city, and right there we are modeling in some way the scenario of the downtown of Bologna, and then you need to identify corner cases, weak detection, and so on. To do that, we acquire data, and then we use our virtual platform for driving scenario, and then you for sure you have the input of interface to the other system, you have the output simulation result, and what you can do, you can improve your functionality, and the loop can go again and again, saving a lot of time of testing to be done on, let's say, on the real life. Prototypes are very expensive, and to move these in a more virtual environment. This is just another example. This is not only for development, but we can imagine that our vehicle can drive, let's say, on the street with a normal driver and can exchange data. And this data has to be in some way filtered, event detection. You see the red one, when you see the red numbers where artificial intelligence needs to be used. So the event detection, you need to store the data, you can analyze the data, you can even improve the functionality, and then you refresh a new software with improved functionality to your vehicle. So this is something that we are testing and that we will see for sure in the futures. This is another example. It's state, let's say, in this case, we are talking about, let's say, state of health for a battery. As we know, electrification is there, and the battery in this kind of battery electric vehicle is today really the most expensive component. So the idea is to maximize the range of the vehicle and to maximize the life of the components. So we are talking about really value that you can touch, not that give benefit to the OEM and even to the final customer. To do that, we are able with this kind of technology to exchange data with the cloud. These data are then, let's say, not on board of the vehicle, analyzed, they are processed, and then can give the input to the let's say back to the vehicle, to the driver, which kind of range my battery has, or which kind of state of health my battery, is in this moment. And this avoid to have for sure to maximize the range. And this is very important because, for example, if you can imagine that one day you have even today an hybrid vehicle in some kind of downtown city, you can have a geofencing. When you pass this geofencing, you can deliver the information of your range, state of charge of your battery, and then they will decide if you can enter or not, if you have enough, let's say, range, to drive in the city without any problem. So there are really many applications related to this functionality. Yeah, and this is some example related to development. So we use in FEV to analyze engine test bench data where we test the powertrain, and then data coming from the vehicle we test on the road. We can put together this data, and with the right modeling and artificial intelligence support, we can then shorten the development time and for sure come to a conclusion to improve the functionality much better. This is an example of digital twin. These are really example of project that we are running now, where you have this kind of digital twin that helps, let's say, to identify at the workshop the failure, the root cause, and the solutions. Okay, last but not least, yeah, I would like to advertise this event. We are sponsor of this event together with Regione Piemonte. It's a vehicle and transportation technology innovation meeting. It's a B2B, so we really invite you there. It will be end of March 2022. Many of the most important companies that we have in Piemonte, but that are coming even, let's say, around the globe, will be there to discuss about this topic, to exchange idea, and why not even to make a business, profitable business, and sustainable, profitable business. Thank you very much.
Thank you very much. Thank you for presenting all those fascinating projects. Thanks a lot. Our next speaker is François Rainville from EFFENCO. So François is currently the Director of Research and Development at EFFENCO. He holds a bachelor's degree in industrial automation from Superior School of Technology in Montreal, ETS. He joined EFFENCO. We contributed to concentrate on electronics and embedded software. He, as EFFENCO's first employee, continued to look further into automating repetitive tasks to improve efficiency. He's been with the company 13 years, and he participated in every innovation project, and he's now leading the innovation team to democratize data engineering and data science within the organization. His goal as a leader is to demonstrate the true power of data. So, Monsieur Rainville, I'll let you do your presentation. Can you share your slides? I think you're on mute. We don't hear you. Can you make sure your mic? Thank you.
You hear me now?
We can hear you very well. Thank you.
Okay, thank you. I'll just have to mix and match the windows.
We could see your presentation. It's perfect now. Yep.
Perfect. Hello, everyone. First of all, thanks for letting me presenting with you today, and thanks for being there. As Aymeric said, I'm working at EFFENCO, where we provide e-mobility solutions for heavy-duty vehicles. We try to aim on the solution that are cost-effective and that meets customer objectives. Our current system is a stop-start system, what's in production right now. So the goal here is to eliminate the idling on the heavy-duty vehicles that are working in the city. During the workday, they have a lot of idling time where the engine is not efficient, and our system help eliminating that idling time, by the same time reducing the GHG emissions for these vehicles. So our applications are dump trucks, bucket trucks, refuse collection trucks, terminal tractors, everything that has a big engine and has a lot of stop time during their workday. As you probably all know, one of the big challenge with artificial intelligence is to have access to a lot of data and quality data. At EFFENCO, we have started collecting data on vehicles since more than 10 years because we were a very small team at the beginning, and our market is worldwide. We needed a way to monitor the performance of our systems, as well as reporting the performance to the customers. And also we can do real use case analysis for the future customers that might be interested. And we also use data for innovation. So in these 10 years, we have collected over 1 million hours of data of more than 150 channels at 20 times per second. We have connected 400 vehicles at the moment, and it's still counting. We have reached that 100 million just in September. It's a fun fact. The first area where we use data is the after-sales service. Our service technician and engineer team needs a way to identify problems either on the system or on the vehicle. And the data is really the best tool for them to find issues when working remote from the customer location, and they can pinpoint the problems and send the right tools or the right parts to do the fix to the destination. We can be more efficient this way. We can also, because the system is connected, we can do remote updates, and it helps a lot on the deployment of different fixes. We are currently working in a machine learning project to detect abnormal conditions in our system, and we have a decision tree algorithm that is classifying them, and then the service engineer can first look at this results and identify if it's a known problem or if it's a new problem. Then we can focus the right resources to address the issue. Another very important use case for our data is the performance report for the customers. Because we have a new technology, customer wants to make sure that their investments was worth what they paid for. So we do advanced performance report for them, and we can show that the system works, and it enforces future sales with the same customers. So this is an example report that you can see. Sorry, I have a problem with my multi-screen setup. Okay, and on the engineering side, we are working on a future system that is a fully electric powertrain for a heavy-duty vehicle, but with a very small onboard energy capacity. The goal is to have a vehicle that is the same cost as a diesel vehicle, but emission-free. So what we need to do for this is we need to minimize the onboard energy, but we need also to, because by doing that, we need to charge the supercapacitor, which is our energy storage, very wisely. So we are working on an algorithm to place the charging station strategically, depending on the use case of the customer. And what we provide as a solution is a path to fully electric. So the first step at 30% is by just buying the vehicle. And the 50% step is when we start to implement charging infrastructure to their fleet. So as time advances, we add more charging station until the whole fleet is 100% or carbon neutral. So this is the kind of an explanation of what this algorithm is doing. We use the collected data to simulate what would happen in different charging location. We do some optimization. Once the solution is chosen and that it matches the requirements of the customer, we can implement that on the fleet. And once it's implemented, we continue refining the model, and we work on the next steps in his path to the fully electric fleet. So let's say the first year he has a specific budget, we could implement 10 vehicles. The next year, the next step, the algorithm could say that they need a charging infrastructure or more vehicle. So depending on the use case of the customer, it will specify what are the next steps to achieve his goals. Thank you very much.
Thank you very much, Mr. David, for this presentation. Our last speaker, so for this first part now, is Davide Sangiorgi from the Fasternet organization. So he will be presenting today connected vehicle technology. So, Mr. Sangiorgi, can you share your slides, or do you want us to show them for you?
Yes, thank you very much. I'm Davide Sangiorgi. I'm very glad to be with you today. Just a minute, I can share the presentation.
I'm sorry, I introduced you as the wrong person, but you are Mauro Nesti from the same organization. Apologies.
Yes, yes. I repeat, good morning, everybody. I'm Davide Sangiorgi. I work in Fasternet. I'm an innovation manager and specialist in business development. Okay, the aim of the project is the use of connected vehicles and onboard sensor to provide a new service for the improvement of road safety and maintenance. The project is into the topic of sensor and connected vehicles and include the communication system vehicle infrastructure. The project aims to develop a sensor monitoring system for suspension that, through the solicitation of the same, collects significant data of not only for the vehicle, but also for the territory on which it passes. The goal is the use of motor vehicle as a sensor of territory and the use of motor vehicle as provider of big data. Black boxes and other devices are used to process and store real-time, especially signals from accelerators sensor. The test is done by the province of Brescia, and many data are collected from vehicles through data providers. The partners of the project have installed sensor into several vehicles and/or use data collected by sensor to validate the method of the province of Brescia. On this picture, you can see the heat map of Brescia's province about a whole image. At zoom highest level, you'll be able to see the detailed information. Big data are used to support the decision to improve safety and sustainability and optimize to maintenance costs and to develop the infrastructure to the interaction vehicle infrastructure environment. Here you can see the information flow chart. Here you can see the information flow chart of the project. The bottom-up approach collects data from the territory using different systems, GPS data, mobile device, digital camera. All the data are collected and orchestrated in a known cloud system. The choice is the use of the cloud orchestrator system to improve the independence from data of the manager providers. Data collected and analyzed provide a wide range of information, increasing the added value of the single information. For a better representation, data are aggregated through tailor-made solution according to the customer experience. On this slide, you can see a sample about the GPS data collection. not only the differences are collected, but also a frame of the trip and the accelerometric variation for every single crash. The data collected are based on mobile phone network data. In this slide, on this slide, you can see a sample about the GPS data collection. Not only the difference, in this slide, there is a simple example. In this part of the road, there are several damages that are collected on the base map. The system includes an application to report damage. There is not only the accelerometer's data, but also coming from the analysis of the image. Images are taken through an application based on the AI that frames the road surface. Not only the analysis of the image, but also a complete set for road maintenance are included in this system. We can find different models for collected focus inspection from road supervisor, collect photo and video with automatic and semi-automatic mobile and fixed system, provide an index of maintenance for road quality network, provide a cost analysis of maintenance plan, elaborate an index for priority maintenance, and so. The collected big data are provided from different sources. The elaboration of data is done from the orchestrator that permits the use of algorithm as the clusterization of data. The position of data is corrected by this algorithm and they are collecting on the exact point of the road. The orchestrator returns the information to mobile app or web interface. We would like to promote a service of data collection through the sensor we interchange with the infrastructure road system to improve the quality of life of the city and in general, the whole environment. The system will be in perspective, open and shared. Thank you very much.
Thank you very much for your presentation. So thank you to all the presentators. Thank you to all the speakers. These were very insightful presentations. We've got about 20 minutes for questions, so that's good. We're on time. So thank you for being mindful of the time that was given to all of you. My first question, actually, I would ask it to Professor Bertogna. Actually, you presented a lot of technologies, in your presentation, in which actually cover a lot of topics. And I would be curious to ask you. Do you consider the potential of artificial intelligence to be still in its infancy or early stage, or are we reaching some kind of maturity level, considering the amount of use cases you've presented? I would be curious to get your opinion on that.
Yeah, that's a good question to try and answer. So when I typically explain a little bit this new trend of AI, I try to explain that this is the third wave of AI. So it is we had two AI winters called, after an initial enthusiasm back in the 60s and then again in the 80s, we had the winters that from hyper premises, not many very commercially ready application followed up. Okay. Of course, now we are in the very, very peak of the wave. Okay, everything is AI, should be AI, even if it is not AI. Okay, so everything from automotive to mechanical system to industry 4.0 to really everything, right? This time, I mean, there are many premises that I think are here to stay, coupled with a lot of, let's say, excitement, which is not so justified. Okay, so. Typical example, so Elon Musk and all these Tesla autonomous driving things. So this is like the fourth year that we had to have already a fully autonomous driving level 5 system ready, but still there is no one there. Okay, so currently everything is level 3, level 4-ish, level 2 yes. Better, and it's very difficult to cover the last mile, right? This last 1% is extremely difficult to do. So also I mentioned we do a lot of autonomous driving. We do have autonomous cars. I didn't show you all the prototypes that we have, but that's not a product, that's a prototype again. So it's not entirely 100% safe to be commercialized and put on the urban roads. I believe we are gonna have it, just I don't know when, you know. So this last 1% is extremely difficult to predict and to understand when it will be ready and will be safely sold, okay? So this is the big part of AI that we still need to address, and that it is not predictable, okay? It doesn't comply with the typical argument of predictability that we typically do instead in the classic automotive, industrial, and embedded domain. Again, so I believe we are reaching the peak, okay? Yes. Most of it is due to the additional computing capabilities of parallel computing architecture that we are able to still increase in performance. I will take just another short minute to try and answer it. So I think that many of you know Moore's law. This is the semiconductor law that essentially increased exponentially the number of transistors in a chip. So essentially the computing capability of a chip. This has been steadily increasing since the 70s up to today. And very simplifying it, so up to like 10 years ago, this was used to increase the processor frequency, okay? So we had every year a more powerful computer, and that this started additional stuff and so on. Now we don't have additional frequency, the frequency is stuck. We have more core, so we have more parallelism, okay? So one of the applications that takes more advantage of parallelism is neural network processing, okay? So that's also why we have this incredible AI hype, and especially on parallel architecture like NVIDIA and so on, okay? So this is a driver that is here to stay, okay? So this is something that will not have a winter, okay? So this will remain, okay? But the big question is whether we will achieve the right safety degree to power up all the nice applications that we are talking today. Also, if the Ville of Montreal will be able to have autonomous and safe bus, okay? Doing a prototype, we're able to do that, but is it safe? So is it able to conveniently deal with unpredictable mechanisms? So this is the big question that we need to answer.
Thank you very much. Very, very interesting. If I would ask the same question to Mr. Sanguedolce from FEV Italia, to get this perspective on that question, but from an industrial perspective, what would be your answer, please?
Yeah, for sure, as I said, we are not a fundamental developer of the artificial intelligence. So my point of view will be a little bit different, Yes. It's not right or wrong, it's just different. For me, today, we could introduce in the automotive, in the product of the automotive, let's say, technology to support the mobility, much more technology available for the customer. So the artificial intelligence that we use to develop our product is there and is already, let's say, able to develop technology for future mobility that can be used. But there is a big but. 2 points. One is the infrastructure. So when the infrastructure is not there, you can implement all the nice function, exchanging data, delivering service to the driver. But if the infrastructure is not there, you can simply not do it. And the other point is the regulatory, so the legal requirements of everything that we can implement today. So from my point of view, again, being not fundamental developer, today we can introduce much more let's say, technology in the product, but we see a limitation of infrastructure and let's say, limits at least in the legal responsibility of any failure. For sure, you can say that in different parts of the world, you can have a different recipe. This is even true, or in different type of mobility. For sure, if you want, you can push the autonomous driving on the highway today much more ahead compared to the urban mobility. If you try to, every time let's say, being in this automotive, let's say, future mobility development, we tested the first autonomous car here in Turin some years ago. By the way, during a first edition of the VTM, and there was a big discussion about the car passing with the reds and so on and so on. When I drive in Torino, and I'm not saying Naples or Palermo, I cannot imagine how the car can drive by itself, no, for sure. So, but for me, I will stay more on what I said before, the limit of the infrastructure and let's say the legal requirements, let's say, are for me something that more close, that if you solve that, you can do much more, no? And then I cannot imagine myself how the artificial intelligence can develop, no? I have to be honest.
Thank you. Thank you very much. My next question would be for Alicia Zarzani. You're an expert in urban design, environmental design. How does autonomous and connected vehicle change the paradigm of urban planning? Is it are you actually taking this into account already, or are you considering those aspects now in urban planning and design? I'd be curious to know what's the impact right now for the cities, you know, who see this technology coming in, and how they prepare for it actually. So
yeah, sure. I think we need to think that it's not to the city to be adapted, but it's to technology to be adapted to the citizen. So yeah, in my regard, we watch and we analyze different aspects of the infrastructure, but the city need to be resilient, but it's not to the city to adapt ourselves to the new technology. So yes, we watch the connectivity, for example, or the cybersecurity for the part of data, and for that we have some policy to protect our citizens. For example, the Montreal Digital Data Charter. We published that in 2020 in October. We start to develop to take to take in consideration some point like the transparency, the accountability, or the flexibility for the city for these different points.
thank you. Thank you. Very interesting. Next question, this time for François Rainville. I'd like to know, following your presentation, is there any new technological breakthrough we can anticipate in the specific niche market you are, or is it a slow actually evolution that we can observe? And I'd be curious to know what's next, coming in this specific heavy vehicle. And
in my point of view, what I've shown in the last slide, the last two slides, is pretty much what's going to be the breakthrough. We have a patent pending on that because offering 100% electric vehicle at the same cost as a diesel vehicle or a CNG vehicle will be probably disruptive to the market. The problem with heavy duty vehicles is that the vehicle is already very expensive, and the quantity of energy on board for doing the duty of this vehicle for, let's say, a whole day is phenomenally big. That's bring us to the fact that it will even more increase the cost of this vehicle that is already expensive. And afterwards, let's take an example of a refuse fleet. If the customer has a fleet of 50 vehicles, use them the whole day, and he has to recharge them all during only one night. So there's a big disruption in what the market is ready right now to accept, to convert their old fleet to electric. So that's what we had in mind when we brought that. We first focus on the vehicles that have a closed road. So the picture you have seen with the Qmap is data from the Port of Montreal. I think you might have recognized. The ports, the vehicle always go on the same road. So and they have some time where the vehicle is stopped. That is an opportunity for the vehicle to recharge its storage. So we want to focus on that and use the really opportunity charging is the key here, and I think it will be the next breakthrough. And yeah, we're bringing that.
Thank you very much. We have a new speaker now for Fasternet, so I will take the opportunity to ask him a question. Good afternoon. It was interesting to see the vehicle being transformed, you know, as a big data, you know, acquisition machine, you know, in the presentation. Is there a challenge with the processing, you know, of this data, you know, to either do it at the edge, which is the vehicle, or actually bringing that amount of data to the cloud where it can also be processed? You know, do you see 5G, for example, being a way to optimize even further the technology you are developing? I'd be curious to hear your thoughts on that.
Yeah, hello, and thank you very much. I'm very proud to be here with my colleague Davide Sangiorgi. Yeah, we use for this kind of process a wide range of data. So it's coming from GPS data, but also from image systems, so collect photo and elaborate image based on in algorithms. About your question, we use a wide range of network. For instance, we use UMTS, but also every kind of network that it could be available. The very value of this project is have a wide range of data and a big range of data for evaluate the whole context of the city. Because our approach is to manage the data in a cloud, in a central intelligence for collect data and for uniform the data for the add value for each information. But one thing is important, is the difference that provide a lot of value, not the uniform. So as for serendipity is the big dreams of the scientists, for us is evaluate and compare different source of data and provide a general index for be assured to the maintenance road manager the correct evaluation about this environment. Because we speak a lot about smart city system like light mobility, but it is the first point to be have a good infrastructure where all the mobility can be moved.
Okay. Thank you. Last question, actually, and I'll probably ask everyone to answer very quickly. What could slow down the current speed of evolution we see in the use of AI in mobility? Is it cybersecurity? Is it data ownership? Is it processing? You know, limitations. I'd be curious to know what could eventually slow the pace of evolution that we're observing right now. And I'll start with you, Professor Bertogna.
Well, just to start from a technical problem we currently have, that's basically chips, so semiconductor scarcity. Yes. So that's an incredible problem that we are facing these days. As I just read yesterday, that the impact of this recent crisis of the supply of this semiconductor in Europe was incredibly high. So it was, if I remember correctly, between 200 and 300 billion euros, okay, just in the automotive domain. It seems an incredible number to me. So that's more or less equivalent to what it takes to build like new semiconductor facilities in modern technologies. So and here, yeah, I know this is Italian-Canadian chamber, but I think both countries are a bit affected by the same problem. Oh, yes. Because I mean, we don't have factories that are able to address this kind of new generation technologies. So we can build a microcontroller level architecture, but we don't have high performance and like in few nanometers technologies that can be developed in the future. While the other main problem, I will not repeat myself what I just said before. So it's safety. So the actual relevance of AI in the application we said is how safe we will be able to do them, and what kind of proof will we be able to do about their safety. So this is a short in time is what I believe are the two main aspects.
Thank you. Alicia Zarzani, what would be your perspective on this?
Yes, in the same way of Professor Bertogna. I think the other point is the cybersecurity, but for the vision of the city. I think it's important is to regulating and controlling that too for the interaction with the part of the infrastructure of the city and the citizen and the other operator. So I think one is control the cycle of the digital life of the data. This is one of the point we developed in the digital data charter of the city of Montreal.
Thank you. Andrea Sanguedolce, can I have your point of view on this as well? What could eventually limit, the speed of development that we are observing right now?
Yeah, as I said, I think that I already gave a little bit my point. What I want to add is that on the last sentence from François about the introduction of the electrification on the medium and light duty trucks. So I'm just coming from a conference organized by FEV, which is called Zero CO2 Emission Mobility, where all important stakeholders and important OEMs were there. And I think this will come sooner than what we think. So I know very well, I am a diesel engine guy. I'm coming from the development. This was my first experience in my job in Fiat in 1999. But today, when I saw the number and the effort that all the industry has to put for the, to change the technology is so high that you cannot afford, let's say, to go, in several paths, but you need to invest in one solution. So I think that we will see much sooner the transition even of the heavy duty application full electric, but for sure you are right. You just touched the point, the infrastructures, to be able to charge. But this is much easier, for example, than on the vehicle, as you can imagine, because this is more within the fleet. You can manage the timing. You can build, megawatts station where you are able to charge in a reasonable way. And so I think that the needs for all these that we are talking about now, the management of the data, the value that you can add is there. And again, I don't want to repeat myself, but let's say political decision and infrastructures, this is for me the big enabler, rather than the evolution of the artificial intelligence. This is our point.
Thank you. François, what could slow you down or speed up your work of development in a minute?
I think we have a big challenge in educating everyone on the planet on what AI is really, what it is really, because not a lot of people understands. People who work on it understands that, people who use it, or university students or professors, but everyone out there, they are not aware of what it is really. And that is linked to the other subject that you have brought, is the data ownership. Let's say we have two customers that are competitors. Will they accept that we use the model trained with their data for a product that we give to or sell to their competitor? Well, their data is not in the product, but it was used to develop it. And it's still a gray zone where what people will accept and what they won't. And I think there's a lot of education to do, and it's going to be a challenge in the next years, I think.
Okay. And Mr. Nesti, you'll be the last one.
Yes, a lot of things are already said, so it's quite difficult at the end to summarize. But I'm in particular agree with everybody. At the last one with François, the data is a value to be sharing. All the data must be sharing. Also, the process must be sharing. In a global environment, there is not a solution. There is a lot of kind of solution, and it is very important to have a global vision of the project. We are in a moment, we are in a period, historical period, we must be very proud to be in this historical period. I talk about, very often I talk about an episode with my daughter that don't recognize a signal fax on the phone. It's quite significant, these kind of things. Probably the daughter of our daughter don't recognize a keyboard or a monitor. We are in a kind of evolution, but first of all, a technician must ask himself if my improvement in this kind of technology, what can be included, what can be provided to the whole environment. We must take a particular attention on what we are doing for the world context. And so also the data must be considered in the world context.
Thank you. Thank you very much. Well, thank you to all the speakers for the first part of this presentations, and we'll be now moving on to the second part, which is the use of AI for simulation and digital twin, which is actually quite a promising technology for my own industry, airports. Our first speaker will be Ruben Ganzaroli from Autostrade per Italia. So he's the chief data officer for this organization, which he joined recently as a chief data officer to support the digital program that was started over there. So he has extensive experience in IT, worked as a consultant with Accenture, Capgemini in both Italian and abroad markets. So Mr. Ganzaroli, I'll let you do your presentation now. Thank you very much.
Hi, everybody. Thank you for inviting us. It's a pleasure to be here. Well, as said, I work as Chief Data Officer for Autostrade per Italia, which is a group that manages about 2,900 kilometers of motorways, of which 4,200 bridges and tunnels. We manage about 4 million clients per day and 2 to 5 million vehicles per day. The company launched an investment plan in 2021 of about 21.5 billion euros of investments, of which 200 million just for a period of 3 years related to digital transformation in order to transform the company in a safe and a data-driven company. Of course, we have a great focus on sustainability, and we have a hiring plan of about 2,900 new hiring within 2024. Well, we are a motorway company. That means that we basically manage traffic. And a specific topic related to traffic for us is safeness, the safeness of our customer. So basically, we started from here in order to understand what AI could potentially do for us. We had three goals. The first was strategic optimization, meaning that we wanted to support our territorial management in managing short, medium-term activities. Let's imagine where to put a safety car in a specific day or on which specific road. The second was the operational optimization, meaning that the support to manage medium long-term activities. Let's think about planning the flooring maintenance, for example. And then, of course, the user support, meaning that we wanted to be able to support our customer to schedule their journeys in a smoother way. Basically, we started developing 2 use cases. The use case 1 has input some static predictors. I mean that the average traffic volume for that specific road section, the heavy vehicle fraction, the average speed, and so on. Then, of course, some weather input data. Again, static, meaning that the average temperature on that road, the average number of rainy days or snowy days, and so on. And of course, the characteristics of the road, like number of lanes, slope, and whatever. We use the tree-based model since this model allows us to join our second target, which is to be able to understand the specific impact each feature has on the calculation we have performed. And our primary target for this use case was to be able to calculate the accidentality risk for a specific road section. In 7 weeks, we obtained a result, as a result, a mean absolute error of 4.9 points versus an average error rate of 13.6. So it's a quite good result. But above all, we are able to understand which feature impacts the most the accidentality on our roads. As you can see, for example, the quality and the volume of the traffic are important features. Moreover, we are able to understand on different road sections the impact of each variable. For example, in this example, we have two roads. Route 1 is a low average curvature. So maybe you can find it in the Pianura Padana, the wider flat in Italy. While instead Route 2 has an average, high average curvature, 55 degrees. So you can find it crossing the Alps or the Apennine. And as you can see, the heavy ratio, meaning the percentage of heavy traffic, meaning trucks basically, almost doubles passing from Route 2 to Route 1. That means that a truck can be more, let's say, dangerous on a straight street, on a straight road. And it could sound quite strange, but it is like this. Maybe trucks drive more carefully when the route is very curvy. And of course, this is more obvious, I guess. The max angle of curvature of the road doubles its impact passing from a straight road to a curvy road. Then we developed the UC2 because we wanted to have not only the calculation of the accidentality on a specific road, but we wanted to be able to calculate it in a predictive manner, so that we used again the tree-based model, because again we wanted to understand the impact of each feature, but we now use also dynamic predictors, so that we are saying that we are not using any longer the average number of rainy day, but we are using the forecast weather in a specific day, in a specific hour, on a specific road section, for example, or the forecasted temperature, again, in that day, on that hour, on that road sections. And again, we wanted, of course, to have the accidentality risk forecast on a specific time frame and the impact, the variable impact again. So basically, as for example, if we wanted today to forecast the accidentality index on a specific street for tomorrow at 4 p.m., we just input the data. Forecasted traffic is basically the forecasted volume. Forecasted temperature, 29 degrees Celsius, the road slope, the lanes number, and we can have the accidentality score pegged on tomorrow, on that road, tomorrow at 4 p.m., pegged by each variable, pegged by the impact of each variable. And another interesting feature of this tool is that we can have a complete map of our infrastructure. In the example, you can see a map for 3 days. It's not Tuesday, of course, it's Thursday. Sorry for the typo, but you see from Thursday to Saturday all the motorway infrastructure based on our sections. Of course, the graph is navigable so that you can deep dive analysis when you see red, for example, in order to understand if there is something that you can do to reduce accidentality risk in that specific time frame. Of course, this is the starting point, but we are developing the full, we are studying the full environment because, okay, it's our core environment. So basically we can use this tool in order to boost the flooring maintenance, supporting the identification of section where to improve the flooring quicker due to the accidentality, the construction site planning, the accident management. Imagine that if you can foresee that on a specific road tomorrow the accidentality risk is higher, then you can put a safety car in that area in order to have the heat ready to catch and to support a potential accident. Then, of course, the customer support, because you know, we want to give our customer the real-time road status and to allow them to schedule their journey in order they are comfortable, they are smooth, and so on. Of course, we have other use cases, not only about accidentalities. We have expected travel time, which is basically a name, but the tool is something more deep regarding the traffic analysis. You know, we have a lot of data about traffic. We can integrate this data to other features in order to understand each aspect of our core business. And this can lead to estimate again the impact of each feature and to put in action put in place some actions to reduce the impact of whatever action we perform or whatever issue we could have on our infrastructure. Of course, we are doing a lot of KPIs. We have a huge number of financial KPIs. We have a huge number of HR KPIs. We are just collecting and managing also the automation of KPI for the asset management so that we have navigable maps so that we can optimize, let's say, we can optimize the travel of our company cars. Last but not least, we are just starting with the ESG program. We wanted to use the SBTi standard because we saw that it highlights what is one of our biggest problem, meaning that for sure the carbon footprint of a motorway company is due to our customers, but you can understand we cannot say to our customer, okay, take the train, of course, because if not, you know, the revenues could be not so good. So what we can do really is to allow our customer to pass good time or less time within our infrastructure. So managing the traffic could lead to a carbon footprint reduction for our company. Of course, there are also, I don't know, we are just creating a system to book the recharge points, meaning that if you take my example, I perform some kind of 800 kilometers per week to go working, and imagine if I have to stop to recharge my electric car, 20 minutes, okay, not so comfortable, but what happens if you arrive at the service areas and you find a guy that has just started recharging his car? They are also other 20 minutes. So a system to allow our customer to book the charging station may lead to a smoother traffic, so to a carbon footprint reduction. Well, that's all. 10 minutes are not so much, but
well, it was very insightful. Actually, it's a very practical demonstration of how you use the data coming in from your infrastructure. Thank you very much. Next presentation is a Professor Gian Piero Mastino from the Politecnico di Milano. His scientific activity is focused on the design, construction, and test of machine structure and mechanical systems, sorry, with particular reference to ground vehicles. So he will be presenting today the work he's doing on a simulator. So to you, Mr. Professor.
Thank you. Thank you. Good evening if you are listening from Europe, or good morning if you are listening from Canada. May I have the presentation, please?
Yes, please. Could it be possible to share the presentation?
Okay.
There it is.
Okay, here it is. Next, please. So I will present briefly the Lombardy Mobility Cluster. Then I move presenting AI and product development, AI and process development, AI and infrastructure development. Of course, just a few examples coming from the experience of Lombardy Mobility Cluster and Politecnico di Milano. And finally conclude. Next, please. Okay, the Lombardy Mobility Cluster is one of the cluster of Lombardy region, and we perform innovation in the field of mobility. Next, please. We work in the automotive, in the waterborne, in railway, and intelligent transportation services areas. Next, please. Referring to our partners, there are 74 partners, 6 trade associations, 20 big enterprises, 42 small medium enterprises, and the yearly turnover of our companies is more than 10 billion euro. Next, please. Referring to automotive, we are ranked first in Europe for innovative small medium enterprises, second in Europe for number of employees, and our cluster is ranked 4th in Europe. Together with Piedmont, we are the first in Italy, and we have more than 50,000 employees which are direct in the automotive sector. Next, please. Referring to waterborne, Italy is the first in the world for market share, and Lombardy the first in Italy for the number of companies. Next, please. Referring to rail vehicles, we have the biggest number of companies in Italy, and the turnover is more or less 1 billion euro. Next, please. Okay, let's come to the AI topic, which is the topic of this session. Actually, we started using neural networks and machine learning techniques to design the suspension systems of cars. This was made starting even more than 20 years ago. Of course, the computer programs at that time were not so powerful as the one that we have today, but we did manage at that time to tune the suspension systems of both current production cars and racing cars, Formula One. The topic here is to design the suspension taking into account a number of different parameters and tires at the same time. Of course, nowadays we use a driving simulator in order to include the actual subjective feeling of the driver. Next, please. what do? We substitute the physical model of the car that is derived by writing a number of equation coming from the mechanical model with a simple neural network that actually establish the same relationship between the design variables of the suspension system and the objective function or performance index. So actually, by means of the neural net, we have the same relationship between, as I mentioned, the design variables of the suspension system and the performance index of the car. Next, please. Just come to the results. One of our last exercises, we managed to optimize 72 parameters describing both the suspension system and the tires, considering 38 different performance indexes that refer to active safety, comfort, noise, subjective feeling of the driver. This, of course, is possible by resorting to AI only. A normal designer is not able to cope and to consider all of these complexity in one shot. Let me go on. Next, please. Okay, so AI is also very much important in process development. There are a number of companies nowadays that in Lombardy that establish a relationship between product and process by means of digitalization and AI. Let us imagine that a component must be derived. I will not mention the component for confidential problems, but let us imagine that we have a component that we insert a sensor into the component while it is produced. So we can use the sensor for monitoring the production, and the same sensor can be used during the service life of the component. During the service life of the component, the sensor will continue providing data, and by means of AI, the important information on how the component is working can be obtained. This data can be used also to improve the design of the next generation of components. This triangle has proved to be really very, very effective in order to reduce production cost and increase the effectiveness of the component in terms of ability to define the actual behavior of the vehicle and the component itself. Let me go ahead. Next, please. Next slide, please. Okay. The Politecnico di Milano is one of the nodes one of the partners, of a European project that is AI at Edge, which is a project that has the aim to develop a proper edge computing that is powered by artificial intelligence. Just to give you an example on a use case, I show you the next slide. Next slide, please. Okay, so what we are doing in this European project, we are developing a kind of a traffic policeman at the center of a roundabout. Please consider that automated vehicles usually get stuck when they get into a roundabout because the situation is quite complex, and often today's automated vehicle suffer the close interaction with other automated vehicles. So often they get stuck there. So we aim to use 5G in order to have those cars connected. There's a edge node per vehicle, and as the automated vehicle get into the roundabout, they get in contact with the roundabout, the traffic policeman at the center of the roundabout, which actually allows cars to be to have a kind of a smooth flow around the roundabout. This might be very helpful even for not only for safety reasons, but also for having a smooth and fluent traffic. Let me go ahead, please. Next slide. So coming to the conclusion. Of course, the AI has important application for the digital twin of the vehicle. We have seen the example in my presentation. We have also a digital twin of the infrastructure in my last example. And of course, it's very important to have a combination of both to perform both advances in the product, in the process, and in the infrastructure definition. The simulation is of course fundamental, and in our case, it has improved. That could be also predictive in terms of designing the components and the vehicle as a whole. For sure, referring to engineering application in the field that we are facing, AI is still in its infancy, despite we started using it 20 years ago. So nowadays we can go more in depth and spread the application, and for sure it is helpful for sustainable. Thank you very much for your attention.
Thank you very much for your presentation. Very insightful, very interesting. Last presentation for today is Maxime Desjardins-Goulet from Centre de Technologie Avancée BRP Université de Sherbrooke. So Maxime is the Advanced Technology Senior Project Manager at the Centre de Technologie Avancée BRP Université de Sherbrooke. He graduated from this university with a degree in mechanical engineering, and along with his expertise in mechatronics and artificial intelligence, he's also an expert in advanced transport system, predictive engineering, metal 3D printing, and structural component optimization. And he will be presenting today some of his work. Thank you. Maxime.
Thank you, Aymeric. Can you hear me properly?
Very well, thank you.
Very good. Hi, everyone. So we'll be talking, as we said, about AI for simulation and digital twins. On the picture on the slide here, you can actually see CTA and Sherbrooke. CTA is a joint venture between BRP, so Bombardier Recreational Product, you may know Ski-Doos and Sea-Doos and these kinds of vehicles, and the University of Sherbrooke. But we also provide the engineering services for other companies. We work a lot in the aerospace sector. We work with the Canadian Space Agency, NASA, and other companies as well in that sector. So first of all, let's talk. Oh, I see that the presentation is not shifting properly, it seems.
Could you have the next slide, please?
Okay, I'm not presenting, you're presenting?
Let me see.
Next slide there, please. I'll try again. Apologies for that.
No worries.
Very good. So physics sandboxes are now key to develop and test vehicles. On this slide, and I will just resume the slide, if possible, to restart the first video. All right, so in the first video, you see a spider, a Qmap spider that's moving around on a track. What's interesting about this digital twin is that the frame is actually flexible. So we can recover the different loads in the structure, even though the whole suspension, the arms in the frame are actually flexing. And that's quite important because it will affect very importantly the loads on the structure. On the second video that we have here, we actually see a rover that we built for the Canadian Space Agency where we do a virtual 6-post in order to determine the loads on the structure. We use these digital twins for many reasons, but one of the things we want to do with these twins is to optimize vehicles. So essentially, we do design of experiment and optimization, and we can adjust, for example, suspension parameters and stuff like that in order to obtain the best trade-offs and the best performance. Here we see, for example, another thing we do with those digital twins where we evaluate the input loads on the structure. On the right side, we can see the same rover from the previous slide taking a bump, and then we can actually make sure that we design it properly. We have to understand that these rovers do not exist when we design them, so they're going to be first shots and they need to be working properly. So we really need to do extensive work and simulation in order to achieve this. On the left side, you actually see a Qmap spider, which is equipped with wheel force transducers and a inertial measurement unit, and we can deduce the loads on the structure using those kinds of instruments. And we can also make sure that we have very high fidelity in our simulation, thanks to that data. On the next slide, we see the MESR. The MESR is a rover that CTE has developed. We used digital twin extensively for that development. We were responsible for developing the lower end of the rover, so essentially the powertrain and the chassis of the vehicle. On the picture, the rover is seen on NASA Ohio Proving Ground. It's been controlled by the Canadian, not the Canadian, the International Space Station, sorry. And it's something we're quite proud of. Using digital twin was essential for that project because we needed to size every single component and also the different motors and the vehicle properly, and to do that simulation was the only way because the gravity is also different for a margin application. On the next slide, we're showing that we're doing more and more driver in the loop. So this is an example that we've done with BRP, where we have an actual vehicle in a simulation, but we can do driver in the loop. So we have someone driving the vehicle and in virtual reality, but we have a digital twin of the vehicle in a simulation, and we can even model the weight of the driver. So by moving around the weight of the driver, we can, force the vehicle to tilt and turn as a real snowmobile world. So this is really only enabled thanks to those digital twins that are getting more and more complex. We also do, by the way, this is an example of driver in the loop, but we use digital twin extensively to do software in the loop and hardware in the loop. So to develop all our algorithms and logics, that's the easiest way we found to make sure they work properly in all conditions before going and doing real life testing. On the next slide, so we talked about the digital twins and what we've been doing with these, at least what's public and what we can talk about. This is an example of AI that we use at CTA. So we have here machine learning, a good machine learning application. So the transmission on the right side is a transmission that has been sold about 100,000 times, and the Qmap Spider, it's a automatic transmission. So essentially, it's automated, and you can clamp the clutch here. So I don't know if you see my mouse cursor, but we can clamp the clutch here by applying a hydraulic pressure. So this is controlled with the hydraulic unit, and essentially we need to do AI, we need to do adaptation because we have parameters that keep changing in those kinds of application. We have a tolerance variation, so from clutch to clutch, from vehicle to vehicle, we will not have exactly the same stack. We will have wear, and we will have also loss of coefficient of friction. So what we do here is we use a machine learning algorithm to identify the slope. Okay, so every time we launch the vehicle and we have a slip in the clutch, we detect the relationship between the pressure here and the clutch torque. And we use AI and we use machine learning in order to be able to understand what's the relationship between these things. And we find the coefficient of friction of the clutch and the kiss point pressure. And keep in mind find that this orange curve will shift to the right during the life of the vehicle because of wear, and it can shift by almost 30%. So it's a big difference, and if there was no adaptation, the vehicle wouldn't simply not be working at the end of its life. So we can actually adapt and make sure that every time the driver requests a certain acceleration, we actually provide exactly what's asked. On the next slide, we show how we use AI here in order to predict trajectories of vehicles. And we can fuse GPS, yaw rate sensors, steering, throttle, and brake, and we can avoid future collision. I will also show you on the next slide, which is a more recent simulation that we have. This is done in Unity. We're using a second-order Voigt-Kalman filter in order to predict the trajectory of that vehicle. So we're using the information from steering, acceleration, brake, and the GPS information, and we have a high frequency update of the trajectory of the vehicle. What's super interesting with this is that we can apply the same logic with the other vehicles around us. So if vehicles are equipped, for example, with CV2X and or DSRC, and they're sending basic safety message with their speeds and location and the GPS position, we can also predict where they will be in the future. And if there is a risk of collision, for example, on the water or in a snow environment, on an off-road for these types of side-by-side vehicles, we can actually predict that there is a collision. We can warn the driver, or we can even force the vehicle to go slower. So on the slide here on the left side, you actually see the trajectories of both vehicles, and we can intervene if there's an actual risk of collision that appears. Finally, we talked about how we use digital twins and how we use AI at CTA, and we can really fuse these two things. And I'm going to show you a little bit the next steps for us in terms of using those, combining those two powerful technologies for the future. So we're beginning to simulate virtual sensors, and what I'm showing here is not our open source code. It's actually LG SVL. LG SVL is capable of simulating virtual sensors in a virtual environment. It works in Unity, and you can actually use GPU. So it's the graphics card of the computer that does the work. So we have very high quality virtual sensors in a simulation. What's interesting is that we can do transfer learning once we have good algorithms, and we can do simulation. We can do software in the loop and hardware in the loop as well, in order to develop, capabilities for our vehicles. So our goal is to use this, okay, to be able to do eventually bots that will drive our own vehicles. So on the next slide, I'm showing you the simulation we talked about before. So this is our Unity environment, and in our Unity environment, we now have a high fidelity digital twin. So we have our vehicle behaving properly, and we have good physics, and we also have a digital environment. We will improve that digital environment by going and scanning our actual test track that we have. We have a test track, and we'll scan it using LiDARs and a very accurate GPS system. We'll be able to get a centimeter accurate map of our test track. And the intent is to move with all of that to my last slide and essentially show you what we can do. So we can use this to develop bots. So our goal is to use reinforcement learning to control throttle, brake, and steering. We want to give rewards. If we stay on the track, we want to give rewards for maintaining high speed and scoring good checkpoint times. So essentially, there will be a mission for the vehicle. The vehicle will have to do something very specific, such as doing field testing and durability testing. But it's going to be doing that. And in our simulation, we will randomize parameters such as weight, traction, for example. So coefficient of friction will make the road slippery and so on. We can change slightly the direction of gravity if we want, things like that, to make sure that the controller that will be trained will be super robust. And once we have all of that, by the way, we will use also cameras and LiDARs and the virtual environment. Once we have that, our goal is to do zero-shot generalization of that to the natural environment. We think we can probably achieve robust autonomous driving. But since this is a closed circuit, it's a closed track, and we will have CV2X capabilities and GPS, we will also have a supervisor that will prevent the vehicle from going outside of bounds. Okay, it will also prevent the vehicle from having collisions with other vehicles. So we have a very safe test bed to do that, and the end goal is to be able to do certain types of durability testing using all of that. That would be the intent. So that was the presentation in a nutshell.
Thank you very much, Maxime. Very, very interesting and great visuals. We have a few minutes left, actually, so I'll ask. I'll have a question actually for each of the presentators. So we'll do it fairly quickly in order to be respectful of the time. The first one actually would be for Mr. Ganzaroli. You showed a lot of interesting models. What's the biggest challenge in being a data scientist for an infrastructure like a motor highway? Is it in order to do some AI, is it accessing the data? Is it the quality of the data? Or is it actually building a well-architected model? I wanted to know your opinion as a chief data scientist, actually.
Well, I guess none of that. I mean, the greatest issue or the greatest showstopper, the more important showstopper is mindset. Mindset in order that we must become able to create an environment. I mean, that I thought before that we have seen some use cases, specific use cases, focused on specific topics, but the point is not to perform some AI calculation or machine learning algorithm in order to understand a specific point. The topic is, or at least in my opinion, should be to integrate all the analysis that you can do in order to create the correct environment. And this is potentially a kind of change of mindset, because we can reason in terms of silos, but we are not so used to think in terms of environment. That's the point, in my opinion.
Okay, thank you. Thank you very much. A question for Professor Mastinou. With regard to digital twins, I know you mentioned there was value in both being an operational tool and a predictive tool, but if I had to promote, let's say, a digital twin in my organization, on which one, do you think there's more value in building such digital twins? Is it would you consider the predictive aspects or more the operational aspects?
Actually, the predictive aspect is important when you design, and you must change a number of parameters. That is, you must define a number of design variables, and you have to perform a computation in a very quick way. So actually, you switch between the model that is derived from physical consideration into a purely numerical model that is actually just a neural net, and this enables to perform computation in a reasonable amount of time that would not be possible if you have a digital twin that is based on physical relationship between the design variables.
Yes. So I assume it would be better to start with a small model instead of maybe looking to digitize something that is very large, actually.
To perform today design, you always have to consider complex models, so simple models are useful only for academic purposes. Okay. Thank you very much. Maxime, last question. I'd like to know how did the specificity of the business you're in, which is recreational vehicles instead of motor vehicles, no typical motor vehicles, impacted, the design of digital twin? Is it very different from the traditional automobile industry? Did it bring you, or did it bring a more
innovation challenge actually to your engineering design process?
It's a great question. Yeah, they are very specific problems with BRP applications. For instances, we don't have lines and our roads are open. So essentially, it's quite a different challenge to be able to drive in those kinds of conditions. We have lots of muds, snow, and other projectiles and foliage and other problems that for the sensors to detect. So that's certainly those are certainly lots of challenges. And then the terrain is deformable. So once you go over it in the muds, you have tracks and you have different types of roads. So that creates certainly a challenge. The tire models are very different than those that are being used for the automotive also world. So all those challenges are quite interesting and add some spice to the game.
Okay, thank you very much. Okay, well, thank you very much to our three speakers, and actually to all the speakers, because this concludes the roundtable on sustainable mobility. I'd like to thank you all very much for your presentation, and also for the insights you brought to us with regards to the questions period that we had also. So wish you a very good day, and I'd like to and I hope you will be attending also the upcoming sessions on this Italy Canada AI Forum. Thank you very much and have a great day.
Thank you, Aymeric.
Bye-bye.
Bye-bye.
Well, thank you very much to all our speakers and panelists. And thank you very much, Aymeric. We heard a lot of interesting thoughts on the role that public and private actors can play to jointly foster innovation. From a technical standpoint, while we seem to be faced with additional and increasing complexity, we know that novel approaches, methodologies, and tech stacks allow us to keep up with some of these challenges and provide new ways to solve well-known challenges, which range from predictive quality of manufactured products to advanced computer vision for safety and to smarter cities, which will benefit all of us, the citizens. In case you missed some parts of today's roundtable, we will have a chance to hear a summary from our rapporteur tomorrow. As a reminder, we will be back tomorrow morning, 8:15 Montreal time, 2:15 Italy time, with a roundtable on digital health. This will be followed by the closing plenary session. I very much look forward to the opportunity of spending more time with you and hearing some thought-provoking speakers and in-depth analyses. Once again, thank you for participating today, and see you all tomorrow.